This is the video on just noticeable differences. Just noticeable differences is a subdiscipline of psychophysics that was uncovered by Gustav Fechner. He was trying to formulate the relationship between sensation, which is a psychological domain, and stimuli, which is a physical measurement. His question was, when can a person detect a difference in a stimuli, or what is the just noticeable difference for a human? He concluded that it depends on the initial stimulus. Let's break this down. If a person has a 1-pound box in one hand and a 2-pound box in the other, he can easily tell which box is heavier. The 2-pound box is 25% bigger and twice as heavy. However, if he holds a 10-pound bag in one hand and an 11-pound bag in the other, it is much harder to tell which is different. The 11-pound bag is minimally larger and only 10% heavier. Both scenarios involve an increase in 1 pound to the object, but the initial weight is different. Another way to look at this is with this picture. When there are 10 dots in a picture, adding another 10 dots to the picture is easily detected. When there are 110 dots in the picture and you add 10, it is not so easy to tell the difference. This is known as sensory threshold. Sensory threshold is the idea that mental events had to be stronger than some critical amount in order to be consciously experienced. Fechner started by determining the stimulus threshold, the RL, the smallest amount of stimulus necessary to produce a sensation. Once threshold was determined, he measured the amount the stimulus must be increased or decreased for the person to report a change in the sensation. This is defined as the difference threshold, or DL. The DL is the measurement of the change in the stimulus to produce a just noticeable difference. Fechner measured these differences in 4 dimensions: intensity, quality, extension, and duration. Intensity is changing the amount. Quality is like changing the pitch of a sound or a color of a light. Extension is the change in size or shape of an object, or the distance between objects. Duration is how long the stimulus is available. We are now going to look at these concepts mathematically. Fechner stated simple differential sensitivity is inversely proportional to the size of the components of the difference. Relative differential sensitivity remains the same regardless of size. This means that the perceived difference is related to the initial stimulus. Another scientist, Ernst Weber, started working on this formulation. He found the change in stimulus intensity that can just be discriminated is a constant fraction of the starting intensity of that stimulus, or delta phi equals c times phi. Or better yet, delta phi over phi equals c. We can graph this out for weights. If a JND for a 10-pound weight is 2 pounds, the JND for a 20-pound weight is 4 pounds. For 30 pounds, it is 6 pounds. This is Weber's law. Weber's law works for intermediate levels of stimuli only. It does not work well for changes seen at or near RL. So, Fechner contributed a change to the law. Fechner stated that delta phi equals c times phi plus a qualifier with a very small value. At intermediate levels, A contributes minimally to the equation. At or near RL, A makes a difference and brings Weber's law values more consistently with the data. This is Weber-Fechner law. Fechner noticed that sight and sound were a bit different in their JND than pressure or other sensations. To produce a better fit to the curves of the data, Fechner derived the following equation for sight and sound. The perceived loudness or brightness of the stimulus is equal to a constant times the natural log of the stimulus over the initial stimulus. This can also be written as the magnitude of the sensation is equal to a constant times the log of the intensity of the stimulus in units above absolute threshold. So what? How does this relate to anything today? It is used quite extensively in today's computerized society. This ends the video on just noticeable differences.